So, Tim, now let's take a closer look at a story that's piqued my interest at least this week, and that is the release of the latest results from our friends over at ML Commons, MLPerf version 3. First off, Tim, tell us a little bit overall to introduce the story.
Sure thing, Stephen. So, training 3.0 benchmark results show performance gains of up to 1.54x compared to 6 months ago, and 33 to 49x improvement over the first round, driving innovation and energy efficiency in the industry. Intel's Habana Gaudi2 ML training engine competes with Nvidia's offerings, boasting better performance than A100 and lower pricing than H100. Nvidia, on the other hand, unveils their NeMo model with 500,000,000,000 parameters and expands the MLPerf training suite to include GPT-3 and a new recommendation engine. Their collaboration with CoreWeave showcases the superior performance of the H100, providing a 3.6x speed increase for GPT-3 compared to Intel Xeon and Gaudi2. Nvidia is also developing foundation models for their DGX cloud, collaborating with major players in the industry, and Intel is widely rumored to be developing its own Gaudi2 as a service offering. Then there's the Tiny 1.1 inferencing benchmark, which saw over 150 results and performance improvements up to 1,000x. This is nuts, Stephen. What do you make of all this?
Yeah, there's a lot to unpack here, and I hope that maybe you and I can kind of dig in here and look at the what's going on in this ML world. I think the first thing that I would point out is that MLPerf is, as I've said before on the rundown, a really great benchmark because it's based on real world tests, sort of like Geekbench, which people are familiar with, and other benchmarks that use real world workloads and run them across a variety of platforms to see how the performance really is. In now with training 3.0, MLPerf even includes, yes, the darling GPT-3 as part of the training exercises for the benchmarks. Now, one of the things I think it's important to know, though, is that there's different flavors, different tests, and not everyone submits results in every test. In fact, from what I understand, Nvidia is the only company that actually submitted across the spectrum, at least on the training side. And of course, there's also the Tiny, which is not training but inferencing, and emphasizes performance with low power on lots and lots of portable devices, like you mentioned. All of these things have been just rocketing forward in terms of performance and efficiency. And it's a real battle here between Nvidia, which is trying to defend their position as the undisputed heavyweight king of training, and Intel, which is desperate to show that they can be competitive in this offering. And then, of course, all these tiny platforms. So I don't know, Tim, which thing should we dive into first? And what questions do you have?
So, I really kind of want to take a step back, Stephen, because for myself and maybe others that aren't as familiar with what's going on here, I kind of want to step back and talk about some use cases. So, is this really a play for edge computing, or is it more centralized? Where is the application starting here?
Well, I would say that the Tiny is definitely client and edge. And in fact, that's really one of the most exciting aspects here. As you said, 1,000 times performance improvement. Now, that comes as no surprise because the devices we're talking about here are tiny, tiny devices. The models, the software has also improved, but the hardware is just leaps and bounds better than it ever was. Think about, your phone. You can run machine learning tasks now. In fact, most mobile operating systems, well, there's kind of two, but anyway, they run machine learning tasks on the mobile devices. Same thing is true of devices like laptops, edge servers, and so on. And this is, as we're talking about every week on the Utilizing Edge podcast, especially inferencing, which is basically doing the work with a machine learning model, is increasingly important all over the edge, from sensor processing, video processing, audios, all sorts of things, image recognition. All that stuff requires good machine learning performance that's balanced by low power. And that's really what the Tiny is showing. Frankly, to me, I kind of don't care what the results are for this platform versus that platform. What I care about is seeing that these edge devices that you asked about are able to perform so much better and basically deliver real useful results with ML models in a low power envelope.
That does make a lot of sense that this would be a large edge play, because that sounds like a problem to me, because you've got a lot of low power, low code devices that are out on manufacturing floors or wherever else that need, could have sensor data, could have data that needs to be processed, and might need to be low latency. So rather than sending this data off to a processing engine somewhere else, being able to do that locally or as close to the device as possible, and leveraging low power to be able to do this level of machine learning, that seems like a huge play.
Yeah, absolutely, and that's really what we're seeing, and I think we're going to just see more and more of that.
Intel is trying to compete with Habana Gaudi2 for training, but also for Xeon. Does it make sense to use a general purpose CPU for ML training?
Yeah, that's I guess kind of turning the page over to the training side of things. This is a really weird situation. So, as you know, and as everybody can probably understand, GPUs are really great for wide distributed tasks like machine learning processing. And I'm sure that most people are aware that GPUs like Nvidia and AMD, and yes, Intel, are really run laps around a regular CPU when it comes to machine learning, especially when it comes to training. Now, Intel has for a while now been pitching a really bizarre concept, which is, hey, how about instead of using a GPU for ML training, you use the Xeon CPU that you already bought and run your training tasks on that. And considering that that's like 100 times slower, it may seem nonsensical to do that. But maybe it makes sense. And we're seeing with every round of MLPerf that no, Xeon absolutely cannot compete with GPU in terms of overall performance and throughput. Um, but but it's good enough that it could be used for ML training, sort of as a side dish, and so the idea is basically you say, oh, I gotta do a training run. I'm going to leave this running while I get lunch, or I'm going to leave this running while I'm in a meeting, or I'm going to leave this running overnight or over the weekend. And the fact is, according to these MLPerf training results, that's actually a viable thing now. So the latest fourth generation Xeons, they've got specialized instructions. They can actually do ML training in that sort of hour, few hours, overnight, over the weekend kind of time frame, and you didn't buy anything. And that's actually a kind of an interesting use case. So yeah, even though it seems like crazy talk, Xeon can be used for ML training.
Yeah, it's an interesting use case, and really an interesting way to market it, because we live in a world now where everything's at our fingertips and we seem to think we need everything at a moment's notice. But there are a number, like you mentioned, a number of tasks, a number of jobs that could just be run over time and essentially in the background as you're off doing other things. So yeah, I definitely could see that being a benefit and a marketing ploy of, hey, you can use Xeon because you already have it. You don't need to buy anything else, and it can do these things over time. But what about the Gaudi 2? Is it actually competitive with Nvidia?
Yeah, that's another result that Intel is touting here. And I guess the answer is it depends. NVIDIA absolutely wipes the floor with every competitor when it comes to absolute performance. And H100, which is their latest offering, really, really shines. I was in a NVIDIA briefing and spent some time asking some questions and poking at it. And I gotta say, NVIDIA has an absolutely killer ML training platform with H100. And it's not just H100, that's the thing. It's H100 combined with a lot of the other things that NVIDIA has. So you may have heard of their Grace and their Hopper combination called, yes, Grace Hopper, that allows you to build basically a massive distributed CPU and GPU complex interconnected with NVIDIA's technologies like NVLink and yes, InfiniBand, which of course NVIDIA also owns now. And the combination was just absolutely unbeatable. H100 is 3 times faster than anything else on the market. NVIDIA talked about basically a much lower footprint, even compared to A100, which was their previous offering. It's 3 times lower TCO than A100, 5 times fewer nodes, 3.5 times less energy to do the same work than A100. So yeah, NVIDIA absolutely kicks butt on MLPerf and kicks butt in the real world with CUDA and ML processing. But that being said, NVIDIA's not been asleep here either. The Habana Labs acquisition that they made was a sharp one, and the Gaudi platform that they produced was pretty good. Now, Gaudi2 is here. We actually got a sneak preview of this at a Tech Field Day event, AI Field Day, in fact. And now it's here, and we've got real results. And yes, Gaudi2 is competitive, asterisk, with NVIDIA A100, which is the previous generation NVIDIA product. That sounds like damning with faint praise, but actually that's not, because Intel's offering this product at competitive pricing. It absolutely does perform well. It's really great. One of the things that Gaudi 2 has is a lot of high bandwidth memory. It's got 96 gigs of HBM, which is more than competitors have. Another thing that Intel's doing that I love with the Gaudi platform is that they're using standard Ethernet. Now, when I say standard Ethernet, I mean 24 100 gigabit Ethernet links per card for interlink. So that's not your father's Ethernet, but it is actually your father's Ethernet. And that's something different from what NVIDIA is doing. So essentially, Intel Habana Gaudi2 absolutely is a competitive ML training platform, and probably cheaper, probably more accessible. I know that NVIDIA has been slammed trying to deliver the H100. So yeah, Intel has a pretty good product on their hands too.
I'm glad to hear you say that, because really having that strong competition is going to do nothing but bring out more innovation in the future as well.
Absolutely.